Hello and welcome to this video all about angles of elevation and depression. So angles of elevation and depression are used quite extensively throughout trigonometry, and they help us calculate heights and distances when things are at a different level to other things. Okay, so for example, if I had a dot up here, but I wanted to know what this distance here was, say, I could use an angle of depression. Or if I wanted to know what this height was, I could use an angle of elevation. So elevation goes up. Put it here, elevation goes up. Okay, and depression goes down. And that's the difference between the two. Okay, so we're going to explore these ideas a little bit in a couple of examples using an angle of elevation and an angle of depression. Okay, our first example here is a park ranger. We have a park ranger. They're in an area where there happens to be a volcano. So probably not anywhere around where I am or we are. But definitely parts of the world have volcanoes. So this could be something that happens somewhere in the world. Walking through their sort of forest, their park, wherever it might be. And there's a plume of volcanic ash spewing out of the top of the volcano. Maybe not necessarily a fully active one, just, a bit of a burp, say, for the volcano. The plume of volcanic ash bursts up to the top, and this park ranger measures the angle that she's looking at from the ground level up to the top of the plume, measures it at a 41-degree angle. So let's start drawing some things in. Okay, so I'm going to pop my little park ranger right here. She's going to wear a hat because park rangers need to have a hat. And we're going to have a volcano. Poorly drawn volcano. Okay, and then we're going to put our little plume of smoke around the top. Some extra grey in there just to make it a little bit prettier. Alright, so there's our volcanic ash. Now, we know that this angle that angle is 41 degrees as an angle of elevation from the ground. So here's our ground. And this angle in here is 41 degrees. Okay, now the next part in our problem is that the distance away from the volcano is 7 kilometers. So we've got our 41 degrees here and 7 kilometers. So this distance is 7 kilometers. All right, so now we've got that distance. We've got everything we need to discover the height of the plume. All right, which is exactly what we're being asked. We want the height of the plume. Okay, so that's this bit here. I'm going to call that X. All right, so we're going to calculate this. We're going to calculate this to 2 decimal places. Okay, so first things first, we need to label our sides. We have a right angle in here, and we have an opposite side, an adjacent side, and a hypotenuse. Here's our hypotenuse. Now, we don't actually need the hypotenuse for this question. What we do need, though, is we need an adjacent side and an opposite side. Now, if you remember back to SOHCAHTOA, the bit that we're going to be using will be this bit. We don't need the hypotenuse, so the SOT and the CAR are out, but we do need the TOA. So I'm going to start with tan because that's the TOA. Tan theta is opposite over adjacent. My next task, substituting. I know that my angle is 41 degrees. My opposite side is x, and my adjacent side is 7. Okay, so now with this one, we just use a little bit of basic algebra. And I'm going to multiply both sides by 7. Why am I multiplying both sides by 7? Well, I've got on one side an x divided by 7. Now that I've done that, I end up with 7 tan 41 equals x. I whack that into my calculator, and I'm going to get x equals 6.085007 and a few more decimal places after that. But I want it to 2 decimal places, so I whack in my approximately equal to sign, round off to my 2 decimal places, which gives me 6.09 kilometers. And as usual, I'm going to use a sentence to finish off since I'm using a word problem. And so therefore, the height of the plume is approximately 6.09 kilometers. That's our first example done. Okay, so remembering that the angle of elevation is the one that goes up. Next problem will be a depression problem. So this one will be the angle going down. Okay, so we've got the problem with the one going down. We've got someone standing at the top of a cliff. We've got Min at the top of a cliff. The cliff is 85 meters above sea level. 85 meters above sea level with an angle of depression 17 degrees. Okay. The first part is we want to know how far the ship is from the base of the cliff, and then we want to know how far the ship is in a straight line from the top of the cliff. Okay, from the top of the cliff. So I'm going to start popping in my diagram. So let's pop in the cliff. I'm just going to do a very poorly drawn cliff. There's Min. I'm going to give him a hat too because he's outside. Alright, and then I'm going to pop in some water. Poorly drawn water for the sea, and then the ship. Alright, so there's our ship. I'm going to give the skull and crossbones. Let's make it a pirate ship just for a bit of fun. So there's our ship. We're looking, first and foremost, for this distance. Okay, so this is our first distance. This distance, I'm going to make x. This distance, out of the question, is our 85 meters. Okay, and then our hypotenuse for our diagram is right here. Okay, and that's going to be part of our second question, so I'm going to make that y. Okay, now, tricky bit with this one is that we probably don't want the triangle that we've just drawn. We want to have the opposite side of that triangle, the bit that makes it now a rectangle. So if you're a little bit aware, you'll know that a triangle is essentially just half of a rectangle. So I'm going to pop in the other side of the triangle. And we're going to add the bits of information that we need to work with this one. So there's our right angle. There's our x. There's our 85 meters. And we still need that hypotenuse of y. Okay. So here we go. We have the hypotenuse. Don't need that just yet for A. We will need that for B. We have an angle of depression. Now this is the tricky bit because the angle of depression is eye line down. Eye line down. So it's this one right in here. And this one is 17 degrees. So this is why this one's a little bit trickier because it's not the angle you think. 17 degrees. So that makes X adjacent and makes our 85 opposite. Okay, so now we're still using tan because we don't need the hypotenuse just yet. Still using tan. So for A, we still want tan. Okay, now we plug in what we know. So we go tan theta, or not tan theta, sorry. Tan of 17 is going to be 85 over X. Now, we could put in 6 lines of working to get to the rearrangement that we need, or we could recognize with these particular problems that we can switch the tan 17 and the X around to get where we need to be. Okay, so we can actually make this X equals 85 over, because the 85 stays in spot, tan 17. It's just a really quick and easy way to do these particular problems if you can recognize that that's what's going to happen within the working. Okay, type that straight into your calculator. Okay, and you're going to get 278.022, couple of dots off. Now we don't need, well, we do need to round off. Okay, we're going to round off this particular problem. It's going to be to the nearest meter, so just 278 kilometers. Okay, so now our sentence for this one is the ship is approximately 278 kilometers from the base of the cliff. Alright, so there's our sentence to finish off that particular problem. Now we want to move on to B. B is using our hypotenuse here. Alright, so we do exactly the same thing, but now we need a hypotenuse. Now we have an opposite side and a hypotenuse. So if you go back to SOHCAHTOA, that's going to be the SO part, or the sine part. We want the sine part. So for B, I want sine theta equals opposite over hypotenuse. Same deal, we're going to plug in things that we know. Alright, we know the opposite side is 85, and we're going to use y for our hypotenuse. Using y for the hypotenuse. And we do the exact same thing. So we're going to switch the sine 17 with the y. So it becomes y equals 85 over sine 17. That's going to get us, when we plug that into the calculator, 290.7258 ... which gives us an approximate answer with to the nearest meter again of 291 kilometers. Again, we do need that sentence to finish it off. Okay, so now we are saying that the ship is approximately 291 kilometers from the top of the cliff. And that's essentially it. That's how this concept works. The angles of elevation are the ones where you're looking up, and depression are the ones you're looking down. Be careful with the ones for depression. It's maybe not the angle you are thinking about. Okay, so that's how it's all done. Good luck with all of your questions. See you in the next video.